Good morning and welcome to our webinar this morning on creating a smart drawing template and also the basics of the PLC IO Utility. My name is Natalie Schrader and I work at Applied Engineering and I teach the AutoCAD Electrical Basics, the Fundamentals course, and also the Advanced course. And these are a couple of tips and tricks that we have from those classes. So first we're going to start with the drawing template. And right now what I have is just a rough drawing template created. You can see here I have my drawing borders as part of the drawing here, and then I also have some title block information down at the bottom here. If I zoom in, you can see here I have some attributes that I've created as part of this drawing template, and right now these are not defined within the AutoCAD electrical environment. This is kind of the starting of the drawing template that you would use when you're creating new drawings within your drawing, within your project. So this template will be applied then to all new drawings created within a project. You can see here in the Project Manager palette here I have this drawing template open. It is just a standard drawing file at this point, and we're going to convert that then into a smart block and then save that out as a drawing template so that when I go to create a new drawing that will be available to me. So first of all, you start off by inserting new attributes. You would define the attributes here. I've done that with a few of these. You would click the Define Attribute command here up in the top in the ribbon. And what that does is it allows you to create a new attribute and insert that into your drawing. So for example here, if I insert the attribute date, I'm going to give it a tag name, and then I can insert a default definition for that. By clicking this little button here off to the right, I can insert a field, and what that does is it automatically populates that information here. So I can select date or create date. I can set the text settings, so the justification to the left, center, right, top, left. You have several different choices here. We're just going to leave this one at left. The text style you can select from any of these predefined choices here. And then you can also do the text height. You can make that larger or smaller, and you can also rotate the text. You can just select whether or not that text will be invisible, constant. You can lock the position, or you can allow multiple lines. So we're just going to insert that here into my drawing template, and then we're going to go through and actually put some of the project and drawing properties. We're going to push those out from our drawing and from our project out to the drawing template. So right now I'm in my Insert tab here. If you don't have that tab available to you yet in your AutoCAD electrical interface, you just simply right-click on here up in the top part of the ribbon here, and you can show tabs, and then you can just select or deselect the tab that you'd like to show. So I've added that Insert tab in there. Next, I'm going to go to the Project tab and go to the Title Block Setup. This is where I can define what information will be pulled from the project into these different attributes that I've created within my title block. So if I right-click on my project, I can look at the descriptions here. I have title number 4, project description, job number, checked by, scale and revision. These are all lines that I'd like to populate into my drawing template. So from the title block setup, I'm going to select method 2, WD_TB attribute, which you can see is found here in my drawing template. Right now, if I look at this attribute, it has no definition. But because I have this in my drawing template, that the default information will actually be populated from this title block setup. So right now, none of these attributes are being populated from my project or from my drawing. And what I can do to map those from the project or from the drawing is actually just from my drop-down menu here, this list is being populated from the attributes that are found in my drawing. and I'm going to map those two values together. So in my title number 4 attribute here, I would like that to be populated by my title number 4 attribute. Excuse me. From the project value, I would like that attribute to be populated. The project descriptions, I'm going to leave those blank. The attribute that I would like for to be populated by the project value job number, I'm going to select job number. This is where it's helpful to create a .wdi file, which is just simply a text file that you would use to map these line items here. You can see this is line 8, 9. These are the default values. You can actually create a custom one so that these line items are actually meaningful information. So I'm going to populate this by checked by, scale, and revision. So all of these project values here that are found by right-clicking in here and going to project descriptions are going to be populated to these attributes. So the next set of attributes I want to populate are actually going to be coming from my drawing values. So the sheet value here, I would like to be populated from my sheet, from my drawing value, and then also the sheet maximum I would like to come from the total number of sheets. Drawing description 1, I'm going to have that come out from title number 2 and title number 3. So you can see here title 4 and title 1, I'll be having that information come from my project, and title 2 and 3 will be coming from my project here. Let's pull that in. The last thing I'm going to do is actually look at the user-defined information. And this is where you can specify additional attributes to either a text constant or an AutoLisp expression. So I want my engineer to be populated by whoever's creating this drawing. So I'm actually going to type in an AutoLisp expression called get environment variable username and update that to my list. What that does is it allows me to actually pull in my username into the engineer attribute. If I click OK now, all of those mapping information that I just specified will be written out to my WD_TB attribute. You can see that here. So that actually creates a mapping file to tell AutoCAD Electrical how to pull that information in from my drawing and my project properties. So in here, these descriptions will all be populated out to this title block once I create the block and the template. And also the drawing descriptions here. So now that I've mapped that information here from my project and my drawing, and also created a user-defined one, now I'm going to save this as a drawing so that if I need to go back and make any changes, I can just go back to this drawing and make the changes there. After I've done that, I am going to go in and write a block or create a block. So I'm going to go back to my Insert tab and create the block. So I'm going to call this one Webinar Block. I'm going to specify my base point, and this is where it can be helpful to toggle on and off your snaps. Select all the objects from the screen to create my block. And if you'd like, you can add a description to that. Click OK. And then what I'm going to do is actually save this as a template. So I'm going to go up into my main menu here, click Save As, and I'm going to write this out as a drawing template. By default, this is going to go into your users folder, App Data Local Autodesk Templates. You can change the location. I could save this out into my webinar folder and save my drawing template out to there. It's by default going to take the drawing name that you have. You can overwrite this, and I can call this Drawing Template Webinar. You notice that this has a .dwt extension. that specifies that this is going to be a drawing template. So now if I want, I can go in and create a new drawing, and I can browse to my new drawing template and actually use that to create my new drawing. So you can see now that information came in from my project. You can see it pulled in my username, and then the other information has been populated from both the project and from the drawing. Gives it a total sheet value. Notice it didn't populate the sheet information here. That's because this sheet hasn't been assigned a sheet number yet. If I wanted to go through back and update that information, I can do a project-wide update or retag, and that will allow me to resequence the sheets. If I do also a title block update at the same time and populate the sheet value and the sheet maximum, then that information will also update within my drawing. So that's the basics of how to create a smart drawing template that populates your information from your project and from your drawing values, as well as user-defined attributes as well. The next thing that we're going to take a look at is how to use the PLC IO utility. The PLC IO utility is a utility that allows you to create drawings from a user-defined spreadsheet. This allows you to create drawings from user-defined spreadsheet for PLCs for the inputs and outputs. It is limited to only using the inputs and outputs. And I'll show you one of the spreadsheets here. So this is the PLC IO utility. It's found in the Import Export Data tab, and it is found right on the right side here in the Import panel. I'm going to go ahead and pull open one of those spreadsheets that I was just showing here. Just to give you an idea of what that looks like. So over here on the left-hand side, you can see there's a code, and that corresponds to the code of the PLC as found in the PLC database within AutoCAD Electrical. Next, you have your rack, group, and slot. This top line here defines which information is found in the spreadsheet. This isn't actually read in by AutoCAD Electrical, but it is helpful when you are setting up the different columns, and we'll get to that in just a minute. Next, we have the addresses. Within here, you can add additional information that we'll kind of go over in the next webinar at 11 o'clock this morning. We have 5 available descriptions for our PLC. Next, we have the voltage for the PLC. What this does is it actually will predefine and pre-annotate the PLC. I'll show you that in just a second here. The information here is just used for annotation purposes. Next, we have the available inline devices. The PLC IO utility allows you to define up to 9 inline devices. Like I said, inline with the PLC address. It is only for the PLC address. It does not apply to any common or ground connections within the PLC. So the next columns here, this D1 tag, D1 description, D1 block, and D1 location refer back to the first inline device. D2 tag, D2 description, D2 block, and D2 location refer to the second inline device, and so on and so forth. The next 4 are the third, the next 4 are the fourth. Like I said, that goes up to 9 possible inline devices. So D1 tag refers to the tag that will be found on that particular inline device. So looking at D1 block here, this is a horizontal terminal. I know that just by the naming convention here. The first letter defines whether it's a horizontal or vertical component. And the T is for terminal. This one would be a horizontal push button. It would be a parent component because the fourth character is 1, which denotes it's a parent, and the fifth one denotes whether or not it's open or closed. One for open and 1 for closed. Excuse me, 2 for closed. So this would be the predefined tag that will be applied to this horizontal push button in line with the first address. So it goes left to right. It'll be a terminal push button, terminal, and then there'll be no inline devices after that until we get to the 6th inline device, which is another terminal. For the terminals, this TB1 is referring to the terminal block that this will be found in. For these components, this will be for their actual tagging information. We'll go over some of the advanced functionality with other things that you can do with the spreadsheet in the next webinar, such as adding jumpers, adding additional attribute information, kind of piggybacking that in, and also adding spacers and breaks and additional sheets between your different PLCs. So right now this is set up for 2 PLCs. We've got 2 codes. We do need to create a space in between the 2 different PLCs. That lets AutoCAD Electrical know that we have 2 different PLCs that will be coming into this drawing. AutoCAD Electrical will read in the information from the spreadsheet as defined within the PLC IO Utility. Right here, this is the spreadsheet to PLC IO Utility. And we do the setup here. This tells AutoCAD Electrical where we want to place the first ladder, how we want the ladder numbered. So this is numbers only, what the width and the distance between the ladders should be, how many ladders per drawing, how many rungs per ladder, the rung spacing, and the run count to skip for the IO start. So this is how many rungs it's going to skip before it starts the PLC. We can define the graphical style of the PLC, the input offset from neutral, and this is for the module, the scale, the IO spacing, and then the number of IOs per ladder. The inline devices we define down here, and that's the first input device from hot bus, first output device from neutral bus, and spacing between multiple devices. This will be consistent no matter how many devices you have, whether you have 1 inline device or 9 inline devices. Each device will have a spacing of 0.75 between them. This is where we can define that drawing template. We could use the one we just created in the previous example. And then here's where we can set up the spreadsheet and table columns. This is how we set up the information to be pulled in from the spreadsheet I was just showing you here. So we want to make sure that those columns match. If we look at the PLC IO drawing generator here, you can see that it's asking for the spreadsheet table or column to data categories below. So the first column here is going to represent our module part numbers. Right now it has the 5th, 1, 2, 3, 4, 5, representing the address. We have 2 for the rack number, 4 for the group number, 1, 2, 3. We should probably change that. So we want 3 for the group number and 4 for the slot number. Once we've updated all of these to correspond for the module itself, then we can go into the inline connected devices. This is where you define what information will be pulled in for the inline devices. You can notice here in my spreadsheet I've actually frozen the first set of columns, and that just helps me to keep track of which one is going to correspond to which address. So here we have the 13th for the tag, 14th for the description, 15th for block, 16th for location. And that's going to keep going across here. So what I would suggest is the first time you go through and set up your PLC IO utility, you would go through and set it up for however many inline devices you think you might be using at a maximum. And that way you don't have to go back and reset up this information each time you want to use the PLC IO utility. You can see here we've got 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, and 9th just by clicking on More Inline Connected Devices. Once I have all of the devices set up, corresponding the information that I'd like to pull for each of those devices from my spreadsheet, I can hit OK, 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 and then I get back to my PLC IO Utility setup, and I can save that information. What that allows me to do is to actually reuse that setup each time I go in and use the PLC IO Utility. And that's why I say I would set it up for the maximum number of inline devices that you plan to ever use. That way you've set it up one time and you can save it out as a .wdi file. And that allows you to actually browse out and read that information back in next time. So you've only had to set it up one time. This is where you can set your ladder reference and numbering, start and index, column to column, drawing to drawing, how you want those numbers to increment, and then where is the module going to be placed? Is it going to start at the top of the ladder, only if it fits, or fill the ladder? You can also allow predefined breaks or include any unused or extra connections. This gives you the option to create a new drawing using either the active drawing, or you can specify a starting file name. If I specify a starting file name, for example, if I use an alphabetic character as the last character here, this will increment by A, B, C, and D. So I'll have PLC A, PLC B, PLC C. If I use a numeric character, I will have PLC 1, PLC 2, PLC 3. This will go on and create as many drawings as is necessary to fulfill the entire spreadsheet. So this time I'm actually just going to use the active drawing here. And oops, I'll use this one. This will actually append these drawings onto the active project. So I'm going to have PLC A as a drawing, and then I'm going to also have PLC 1, PLC 2, PLC 3 as needed. I have the option to pause between drawings. This allows you to review the drawing before moving on to the next one, or you can do a free run. This allows AutoCAD Electrical to just create all of the drawings as necessary, and then you can go back and review them. You have the checkbox here to add the new drawings to the active project. If this is not checked, the drawings are just created but not actually added to the active project. So now I'm going to start. You can see here it goes through and adds the module, and then one by one it's going to add these inline components. So if I turn my grid snaps off here, you can see where that description information has been annotated and the addresses have been annotated out from my spreadsheet based on the information I put in there. This allows you to create a similar set of drawings, but by easily changing the components that are in line or the descriptions that are in line, just based on the spreadsheet itself. Are there any questions? Are there any questions?
You were there?
Well, thank you all for attending this morning, and hopefully you will be we'll see you back again for part 2 in about half of an hour, where we'll go over a little bit more information on some additional functionality with the PLC IO Utility. We'll go over how to create inline circuits with the PLC IO Utility, so adding jumpers to the PLC IO Utility or adding those into these ladders here, how to piggyback attributes on there, and also how to predefine parent-child relationships within the spreadsheet as well. We'll also be covering how to annotate wire information onto your footprints in the second part of this webinar as well. Thanks.